This morning's topic is automation done right. With the need for social distancing and adjusting for possible staff shortages due to COVID-19, automation is more valuable than ever. So, when and how should you automate? How can it provide not just cost savings, but value added? Are 3, 4, 5, or 6 axes right for your job? And where do the new cobots fit in? To help provide some answers to those questions, today's first speaker is Dino Caparco, Engineering Operations Manager of Yushin America in Cranston, Rhode Island. Dino has worked at Yushin for 23 years and has worked with manufacturers in industries including medical, consumer goods, automotive, and packaging. Today, Dino will talk about choosing the right projects to automate. So, Dino, the audience is yours.
Thank you, Matt. Good morning, everyone. As Matt said, I'm going to discuss choosing the right projects to automate. Very often, we've got customers that are interested in starting up automation projects or automating a process, and they really don't know which project or process to choose first. So hopefully, I'll be able to give you some insight and some guidelines that will be beneficial to you when you're choosing your projects. So the first thing I'm going to talk about is assessing your level of competency. It's really important when you're thinking about automating. And then we'll look at identifying opportunities and evaluating the benefit or the return on those opportunities. We'll also talk about some value-added operations that you can do within the automation. And then we'll touch a little bit on some cobot applications. So the first piece of it is really important because when you're automating anything, you really have to have the staff internally to support the automation. So you really have to look within first to understand what your abilities are or what direction you should go. So, are you currently using automation, and to what level are you using automation? Are you using basic pick and place robots, maybe some more complicated assembly automation? And then, what's the culture like? Are the folks ready for automation, or are they scared of automation? Sometimes we see people that are not very receptive to it because it's something new. And then you've got to have the staff to support it. So are you able to support the automation that you currently have, or you're currently looking at, and also how that will transition in the future? Are you able to support where that automation is going to be, the level of automation that you're going to want to be at? And I mean, there's a lot of basic troubleshooting processes that would be beneficial to help support the automation, electrical, mechanical, pneumatic skills. So there's different sets of skills that would help the staff be able to support the automation. And then you want to evaluate where you're at to determine what level makes sense. So a lot of times you can phase in more complicated automation. So if you're not really where you need to be from a staff perspective, you may start with components of automation and then phase the rest in. So then when you look at identifying the opportunities and evaluating the return from those opportunities. So obviously a big benefit is labor savings. And as Matt said, a lot of times folks aren't able to get people in the facility. Even pre-COVID, many people were having these issues, and now it's just exponential. So obviously you're going to get reduced operator utilization. Sometimes you can even just gain a benefit with reduced mold open time. You have semi-automatic versus fully automatic opportunities. So you've got, in some cases on a semi-automatic automation, you'll be able to gain some pretty good benefits. And you don't have to go to fully automatic equipment. The other piece of it is quality. A lot of times customers, there's qualitative data and quantitative data. The quality is important in many products, more important in some products than the others, but you're going to get a more consistent cycle time. Sometimes people have to place parts for cooling, so you need to queue the parts up for a period of time. That can be easily done with automation. And of course, you've got inspection. And then from a safety perspective, if you're going to, if you're having an ergonomic issue or some type of hazard condition that the operator is exposed to, obviously that's something that the automation can help with. So some of the obviously some of the biggest bang for your buck high run volumes. If you've got parts that you run for a good portion of the time, those will be some projects to attack. Also, if there's similar part families, a lot of times we can automate multiple parts with little or no changeover. So if they're similar part families, similar cavitation, with just some slight differences, you can get a lot of gains by automating those part families with the same equipment. And then you've got to look at things where you're going to get potential cycle time reductions. Insert molding applications are usually a big target. We get a lot of customers that are looking to automate insert molding applications, because you're going to be able to reduce the time that mold is open, and it's going to just be able to produce more parts. And also, a lot of times for insert molding applications, it isn't really a safe or optimal condition to have an operator reaching in the mold, but it also creates a very inconsistent cycle time. And then automating components of a project. I'll talk a little bit about that later. I'll show an example of it, but sometimes we've got folks that come in looking to automate some type of project or process, and some components of it may be really complicated or maybe really expensive, so it doesn't make sense really to do all those components, but you can do some components of it. One thing that I always like to look at is I really like to try to see what the benefit's going to be. And if you look at whatever you're targeting for automation, and you just try to shake out what the benefit's going to be, whether it's labor, scrap reduction, increased productivity, safety, or quality. This is something that we kind of are always putting out there when we're talking about projects with customers, or we're talking about projects with our sales team. We're looking to find out what the benefit to the customer is going to be for that particular project. So there's a lot of different variables, but if you look at the variables and you understand where your benefit is, it's going to help you. It's going to kind of guide you to those projects that are going to give you the biggest bang for your buck, are going to make the most sense to tackle. So a couple of operations. I've got two illustrations here, one on the left-hand side and one on the right-hand side. The one on the left-hand side is a semi-automatic insert application, and this is a very typical configuration that we would do. It's basically got what we call a two-bay or two-zone station. So what this does, it allows the robot to deplete inserts from an operator-loaded station, so that the station is loaded offline and it doesn't interrupt the cycle time or the mold open time. And basically, the operator goes by and loads two stations up. The robot depletes the first station, and any time while the robot is depleting the second station, the operator can go back and replenish the first station. So it gives the operators flexibility to, within a certain duration, go back and replenish the inserts so that the robot's running uninterrupted. Now, it depends a lot on the number of inserts, cycle time, geometry of inserts, locations, and things of that nature. But a lot of times you'll be able to get put a piece of automation like this in place where it's not too costly. You're not looking at expensive bowl feeding equipment, and it's a semi-automatic process, but it really gives you a big gain where you're not keeping that mold open. And in some cases, if it's a really large mold, it'd be difficult for the operators to load the inserts in. And on the right-hand side is a similar type of a piece of equipment, and this is for a different insert. This is more of like a blade, a thinner insert. So what this one allows us to do is the insert Q station or the magazine station is outside of the guarding, and what will happen here is the operator can go and replenish those basically at any time. They can go and put more inserts in. Something like this, again, depending upon the inserts or the the size and shape of the inserts. In this particular case, these folks are getting a couple shifts where they're able to run without having to replenish the inserts. And it gives the operator flexibility if they're working on several machines or they're tending several machines. It's a lot easier to gain a benefit with a portion of the operator. So you can see with those two pieces of automation, very easy for one operator to tend both of those part-time and still have capacity to perform other operations. And then we've got one that's a little more complicated. This is a vertical injection molding application, but it's got all of the, it's got a bunch of different facets into it. So it's still got the two bay, the two zones that the robot would deplete and the operator would load. But after that, it's going and it's doing some cooling. It's doing some inspection to ensure that there's a metal band on these particular inserts, and it wants to check to make sure each one has a metal band in it. And then it's also degating. It's cutting some runner drops from the parts, and then it's going and bulk loading the parts. So there's several processes that they were able to automate with this system, and essentially they're getting fully inspected full boxes out of the automation. A little closer look of it shows, you know, the station with the cooling station, and then there's nippers that are cutting the runners, and then there's also sensors that are inspecting it. I've got a little video clip showing us running this off at our facility. It's extracting the finished parts, putting the inserts into the mold. It's actually pushing them down to make sure they're seated properly. That's simulating dropping the runner. Then it's going through, it's taking those parts, putting them in a cooling station. Now it's taking the cooled parts and bringing them over to the degating area. It's degating and inspecting at the same time to ensure that the inserts, the metal bands are in the parts. And then it takes it and it either discharges them to the box load location or to reject, which it looks like it went to in this case here. But that's a good illustration of, you know, several components or several processes being done within the automation. This is another one that we've got here, and this kind of falls in the category with the part families. This particular customer had a number of different parts, and they really wanted to automate it. The parts were studs, and they were different diameters. Some were threaded, some weren't threaded, different lengths. So generally, if you had one product that ran quite frequently, it might make sense to put a bowl feeder. But when you're running a dozen or so products, it really doesn't make sense to do that, or it could be more cumbersome, it could be more expensive. So in this particular case, we made a semi-automatic piece of automation, and the customer will load the inserts in, and then it does an overmolding process, and then ultimately they get 100% cavity separation by just putting the insert to a separation station. This is one that evolved a little bit when we talk about looking at what components of the project made sense to automate. This customer actually came to us, and one of the specifications was that all of the threaded posts had to have a little rubber boot put onto them. So when we went through the quoting process with them, we worked on that benefit there and to discuss the benefits with the customer. And, you know, right away, we were able to kind of push out that, you know, for us to automate putting the boot with the different size, lengths, diameters, it really wouldn't make, it would be cost prohibitive and wouldn't make sense for them to do it. We said, however, but since we're doing a semi-automatic system, why don't we have the operator that's tending and loading the inserts in? Actually, when the overmolded parts are done, they can physically put the boots on the parts while they're loading the inserts onto the station there, and then they'll be able to, then the end of arm tool will take the parts, it'll still retain them with the boots on and take them to the separation station. So in this case, that's what we did. So just by taking that piece of it off, it was a much lower cost, much less complexity. And what we also did here, as you could see in the view on the left there, there's a plate, and that plate works for several different part numbers. And we've actually identified on the plate there that which products it works with. But the plates are located and pinned in place so that when they remove it and replace it for another part, the next product family or the next insert station, they're able to put it in the same spot, and it's not going to be extensive teaching or extensive setup. So now I'm going to talk a little bit about the cobot applications. It's quite a bit of buzz about cobots, and a lot of folks, especially management, are seeing that there's some type of benefit with collaborative robots, and they're asking us to they're asking their people, we've got to get a collaborative robot in here. We've got to do some type of application with it. And a lot of times when we go to facilities, we see collaborative robots just in the corner collecting dust because they really didn't have a plan in mind or a project, or really didn't know how to approach it. So what we've learned and what we try to do is the first thing is, especially if it's new to you, it's ideal to target redundant tasks that are being performed by an operator. Not really every application is going to be a great fit for a collaborative robot. So if you're just learning about them or just starting with them, the best thing to do would be really to start with that low-hanging fruit, just so you kind of get acclimated with the robot and understand how things are done. Lower speed tasks, less complicated tasks, and once you start working with the collaborative robots, there's quite a bit that you can do with them. You can interface them with other pieces of equipment. And the more projects you do, I think you can increase the scope and the complexity of the projects that you try to target, you try to work with. Generally, they're pretty easy to work with once you understand how they work and maybe get some tooling or grippers or different components for them. I'm going to show you a couple of applications here. The first application is really just a basic repetitive task. So this particular customer is making a food product, and they've got 3 different SKUs, and they have full boxes coming down a conveyor line. Previously, they had an operator that was taking the pamphlet for that particular product and just putting a pamphlet in a full box. They have to ship a pamphlet on the top of the full box. So they went through and they automated it with a collaborative robot, and they interfaced to a barcode reader. So now all day long, the collaborative robot gets the signal for either product A, B, or C, and it puts pamphlet A, B, or C in that box. This video was taken during the testing of the first one, so not all 3 magazines are in there, but pretty straightforward and basic application. It interfaced to the customer's existing equipment, and the collaborative robot actually, because the quantities of the boxes coming through could vary, the heights of the magazines would be depleted at different rates. So there's actually a sensor to detect the height of that particular magazine that the robot's picking from, so that it goes to the right height to pick the pamphlet and then to put the pamphlet into the box. So, kind of a basic application with a little more complexity built into it, so that we can achieve what we need to achieve with this application. So this one's a little more complicated. This is a vertical injection molding application, and essentially they're doing an overmolding process, and there was an operator that was loading some type of cores that go into the mold with the inserts, and then there was another operator that was taking those loaded cores and putting them into the mold. So the initial operator is still loading the cores, and now the collaborative robot is picking the cores from a position, removing the overmolded parts, and putting the cores into the mold. And then this is another case that it works out well. They're kind of in the testing process here. It actually goes a little faster, but it allows them they're molding in parallel to this happening. The mold's closed, products being molded, and they're just working outside of the molding the molding process in this particular case. And little tips to make things friendly. You always want to have lead-ins and we call it automation friendly. Rounded edges tend to be more friendly for the automation when you're picking and placing. Anything that you could do to relieve the accuracy or the complexity that's required is going to make it more friendly for the automation. And I think that's all I've got. So I'll turn it back over for questions.
Okay, thank you, Dino. That was very interesting. In fact, I'm very glad you emphasized insert molding as an application for automation, because we happen to have an article coming out in our December issue on automating insert molding. So I hope people look for that. As far as questions, I know robot suppliers like you like to show all the various things that you could do in terms of in one cycle. You could do multiple operations. Can it still be cost effective to have a robot do no more than just pick the part out of the mold and lay it down on a conveyor or a table or something like that?
Yeah, absolutely. Absolutely. A lot of customers are doing some pick and place applications. And there's a number of reasons why why they do it. But it can certainly be. Servo robots now are a lot less expensive than they were years ago. In many cases, customers want to pick parts, so they allow them to cool, and then they want to pick them and queue them up and stack them. A lot of times, you can get, if you're packaging or loading parts into packages with a certain number of parts, you can have the robot stack them on a conveyor, and they can be packed onto the conveyor and indexed out. And then periodically an operator could come by and put them into a bin or put them into a box. So you already have your count done. That's probably a huge benefit alone there. So now you're not having operators counting the parts as they come out. The parts are stacked, counted, or in their queue so that they can be packaged or boxed.
Yeah, I've seen a number of shops where they have a person doing secondary operations on the parts after the robot takes them out of the mold and sets them down. And it just seems to me that they obviously don't have to have a person standing at the press to do it, so that frees the operator to do it. So that sounds like it could make sense. Yeah. Now, you mentioned there's a lot of buzz about cobots. And initially, when they came out, people said, well, a cobot's not good for press tending. It can do stacking, packing, that kind of thing. But they seem to have gotten better, the cobots themselves, more accurate and this sort of thing. And I have seen applications where cobots actually load inserts and remove parts from the mold. Is that something you would recommend?
Well, I showed in one of the videos I showed, and we did it with a vertical injection molding application. And essentially, in the video I showed, it was acting more like the operator. So basically, it was interfacing with the light curtain and giving signals for the push button. So it worked more in the manner of an operator, the way an operator would. And certainly, we've seen a lot of other applications where it's picking and placing. But one thing that you have to keep in mind is that once you start working with a molding machine, if you're keeping the safety gate open, now you're going to have a hazard condition, so you're going to have to guard it. A lot of times the benefit of the collaborative robot is that it can work in proximity to humans. Once you start guarding it, then it becomes questionable. For most applications, when we're talking about extraction from the mold, we're looking at takeout robots, top entry robots or side entry robots.
Okay. Now, you get all this automation set up to do a particular job. How do you handle the changeover when you've got a slightly different job to do? Can you?
Okay. And actually, changeovers are really important. In one of the videos that I showed there, you really got to put a lot of thought into them on both sides, on the automation side and on the molding side. So the changeovers really shouldn't be extremely cumbersome. A lot of times when we're doing multiple projects, like the multiple products, like the photos that I showed there, we ask the customer to locate the mold to the platen so that when they remove the mold and put another mold in, or they do some work on the mold, the mold is going in the same exact spot. So they don't have to start reteaching in mold positions and realigning the robot. So, radially around the ring it's located. And then for the downstream, a lot of times what we do is we recommend locating the changeover components. You have everything pinned and located so that once you've run it off, you can get it in the same spot. So when you're doing a changeover, you're just putting it back in that spot. You've already got the top positions, and the robot will go back to the same position. So it's really important to make sure that you're able to put things in the back in the same exact position. So locating features are extremely crucial.
Mm-hmm. At trade shows, again, companies like yours love to show off fancy stuff like automatic end-of-arm tool changers for robots. Yep. Is there much of a real market for that kind of thing?
Yeah, there is actually. We do quite a bit with automatic tool changers, and many companies that are doing. There's some companies that can change their tools, their molds very fast. And with an automatic tool changer, it's just a matter of selecting the program that you're running, and the robot will go over and drop off the tool that it currently has, and it will pick a new tool, and then it will also check to make sure that the tool, the program, and the mold are all the same ones that are, that you've called up and are working together. So we do see quite a bit, and it's becoming more popular to use quick change tooling.
Good. How about vision? You mentioned a sensor on one of the cobot applications. Is vision becoming a more common thing to see?
Yes, vision is very, very common now. We get many applications with vision requirements, whether it could do basic part inspection, like presence or absence of parts. Mm-hmm. And then it can start doing some more complicated inspection, checking for flash, checking dimension, checking for features. So in many cases, we're implementing vision into our automation cells. And there's a lot of, Keyence does quite a bit with vision, and they've got a pretty good sales force, especially throughout the United States. And a lot of times we try to work with customers based on who they're using, or we'll recommend somebody for them. And we try to, when you're working with vision, one of the important aspects is that you want to have the vision checked ideally in the environment that you're going to be working in, because you can do a lot of things in the lab in a nice controlled environment. When you go out to your molding floor, your molding environment, lighting, debris, vibrations, different things can impact it. So that's one thing that you want to be conscious of, but certainly it's becoming more user-friendly.
Yeah, great. Okay, well, we're coming right up on the bottom of the half hour here, so I want to thank you. This has been a good start to our program today, so thank you.